Welcome to Catamaran Conversations, a deep dive into the world of catamaran design with Berman, founder of Balance Catamarans, Patrick Shaughnessy, president of the esteemed Far Yacht Design, and sailing writer and journalist Herb McCormick. You are watching the 7th episode in this series. If you're joining us for the first time, you may want to click over to episode 1, Designing a Catamaran from the Inside Out. Find the full list of episodes linked in the card above or in the description below. Now, let's pick up the conversation as we look at the pros and cons of carbon fiber construction.
Welcome back to Catamaran Conversations. In our last installment, we talked about sail plans and sail inventories. This time around, we're going to get into carbon fiber construction. Patrick, I know how far as one of the leading builders, cutting edge builders, you've done a lot of work with carbon, which has become, it was a kind of controversial building material and has become more and more mainstream. And obviously it's lighter, faster, but there are considerations you have when you're building carbon. Why don't you, as a naval architect and a builder, take us through the overall pros and cons of carbon?
Right, so I guess when you're constructing a boat, like when you're constructing anything, you have a range of materials that are available to you as an engineer when you're trying to solve the structural, problems that you're facing. And carbon fiber is one of those materials. And when it's placed in its resin matrix, it offers some benefits relative to other materials. And so its stiffness for its weight can be superior to fiberglass or Kevlar or, these kinds of things. And so you have trade-offs that you can make just like anywhere else in engineering. And so really what we're looking at is how we trade off the cost of using a more expensive, higher performance material against a less high performance material at a cheaper cost. And so carbon fiber, I guess, first made its way onto boats as a mainstream material probably in spars. Obviously, very high-end race boats, America's Cup level boats, these kinds of things, are the first boats to explore carbon fiber, construction all the way through the boats maybe. But gradually, these have become, pretty mainstream materials for construction. And so what a manufacturer does is they try to balance the engineering requirements to have a material with the wants of their customer, maybe in some amount in fashion sometimes or image, and try to balance those things as offerings that make sense for their customers. And I guess balance is much like that, right?
Yeah, with a balance, initially when we started with the 526, the idea was to do the boats in all epoxy and to use carbon fiber in all the really high load areas. So if you went into one of our boats in the factory, you'll see the primary bulkheads for the beams, and you'll see the any area, structural area, where you really get a lot of benefit from carbon because you can reduce the laminate schedules. That's a really wise use of carbon. It's important, of course, to note that when you impregnate carbon with epoxy, its strength properties are greater than if you impregnate it with vinyl. We also use the carbon fiber in all the high load areas on the New Balance 464 and 502. All of our boats, we've always used carbon in all the high load areas on the boat, but we now also are using it in the soles of the boat and in the bulkheads and in the appendages, because we've noticed that we can really achieve great weight savings from those things without massively increasing the cost of the boat. We also offer on the 526 and all of our larger boats, we'll do them in all carbon construction, what we call the XP. I think Patrick and I had talked about this earlier, that the performance differences between the all carbon 526 and the standard 526 are not massive. Like if you ran the polars on those boats, and you're talking small amounts of a quarter knot to a half a knot, maybe something like that. But obviously for considerably more money. And so it becomes this question of, value. And then some people will order carbon enhancements on our boats because they want to buy more payload capacity without suffering any performance degradation. So for example, if they want to get the coach roof in all carbon, we can do that for X price. And we can give them the exact amount of weight that they'll save for doing that, or for the appendages, or for other things. One negative of carbon is obviously if you do an all carbon boat, you you've got some issues with your chain plates and stuff with electrolysis and how you do that. It is a noisier material when you're sailing, though. When you're blasting along in a 526 at 18, 19 knots, it's noisy even if you're on a standard boat. But the E-glass has a little more give to it, and the carbon is a little bit more like a drum. It's very, very stiff, has very, very stiff properties. I think there's no question that it really helps a lot to use it in the high load areas, and we feel really, really strongly about doing that. As far as carbon fiber spars are concerned, when you've got a carbon fiber spar, you can get different moduluses of carbon, right? So your standard modulus carbon, which is what most people get, you've got the tube. You have an aluminum tube and you stack it next to a carbon tube. What's the difference in weight between those two things? Well, when you actually dress both the masts with all the fittings and all this stuff, it's only about 17% weight savings, something like that. I mean, give or take, depending upon the spar. So the amount of weight savings you get from a carbon mast are not like massively significant, but you're saving the weight in the right place because aloft, right? You reduce it. But also the carbon mast is stiffer, right? So it leads to a more powerful rig because your mast isn't bending in the center, right? So you get more power out of it. I was talking to the guy who's a retired carbon manufacturer. I won't mention his name. And he said, well, Phil, these carbon masts are a big old Christmas present. He said, if your customer has the money, it will reduce pitching, and it does save a little bit of weight. I think that some of our customers, what they do to reduce weight aloft is they get an aluminum rig, and then they'll get Future Fibre's high-tech rigging, and then they'll get light sails, string sails, because then you can really reduce the weight aloft. And that's obviously important with a cat because the monohull is like this, and the cat's like that, and so reducing that pitching is obviously really important.
Yeah, the way pitching works is you have sort of a weight thing, and it's distance from the center that the boat's rotating around, and that distance is a squared factor. And so things farther away from the center that the boat's moving around are more important than things close to the middle, right? So anytime you can take something that's 6 meters away, the square of 6 meters is pretty powerful, right? So that's why pitching and those kind of motions are better attacked, farther away from the center. I guess the one other thing I would say also is just analogy-wise, there are places where carbon fiber isn't the right thing to use. And most people have probably experienced a carbon fiber bike. And a carbon fiber bike is so stiff usually that it's uncomfortable to ride. And so it might be lighter than our steel bike that we used to have, but a steel bike might be a much better city bike than a carbon fiber city bike. And that doesn't sort of apply all the time, but on a boat, you'll face a decision like, we're looking at an OC tender for our boat and it's available in all carbon fiber. And you can save quite a bit of weight in a carbon fiber boat. But probably the skin thicknesses also end up quite thin. And so the robustness of the boat, how you're going to actually use your tender, might lend you to a path where you'd prefer to have bigger skin thicknesses, at which stage you may as well have had the E-glass construction, probably. So there are times when carbon fiber isn't always the right answer. And it's difficult as a consumer when you're trying to improve a product to understand really where the right places are to improve the product. And that's challenging, for sure.
Yeah, definitely. And it was crazy during the pandemic how much carbon prices went up too. It was just, there was a period where we were having a really difficult time getting our carbon.
That was a supply-demand deal?
I guess it always is. Yeah.
I think it's supply chain combined with military need.
Military needs, supply chain things. Things are better now. We can get the carbon fiber. I find the boats they're fast. They're fast. So it's really just a question of do you want to go even faster, right?
Patrick, Phil was just talking about using the use of carbon in high load areas on the balance line. From an engineering standpoint, what is the benefit of that?
Well, if you can imagine that if you had this load across this beam, and it required 50 layers of e-glass, or you could do it in 20 layers of carbon. And in that example, it might be that the material costs for the carbon are slightly higher, but you reduce the man labor laminating it, or you got an easier part to laminate, or to laminate correctly every time. So there could be places like that where carbon fiber is sort of a no-brainer to use, right? And so the high load areas, that's sort of a broad phrase that's applied to parts of the boat, and the ones that Phil sort of listed, your dagger boards, some of the bulkheads. These are going to be areas where you're transmitting large loads, and you're trying, in the situation of bulkheads, you're also trying to reduce internal structure to provide large livable volume, right? And so when you have less structure, it's more highly loaded structure typically. And so then you're trying to transmit those loads somewhere. There can be other parts where it's just, there's simpler parts to make that way. It's reduced labor. So it's not as simple as people might think. But certainly when you're engineering a boat and you're running the equations on specific areas, it jumps out at you. This is an ideal scenario to get better material in.
That's kind of the way it is, right? Because you're doing laminate schedules and measuring that with the strength properties required for the area that you're dealing with, and it usually hits you in the face, that you really get that benefit. Yeah.
Patrick, I'd like to hear your I've heard Phil's take on carbon spars, and wondering what your view and the view of Far Yacht Designs is on carbon spars versus aluminum extrusions, and also with the use of carbon in cross beams.
I think all things being equal, if money is not an object, you would use carbon fiber in all of your spars. You can either make smaller parts, reduce windage, or have some flexibility in the tooling geometry, reduce weight aloft, these kinds of things. So it's kind of a no-brainer. The problem is that cost is an object in many of these things. And carbon fiber spars are relatively expensive, not just at the moment, but traditionally. And there are still some quite suitable aluminum extrusions for the boats that suit them. And you can get pretty decent aluminum rigs for boats. For us personally, that's the way we'll be going. There'll be an aluminum spar for the boat. And I'd rather focus the budget that we have in other places where I think it can gain more for us. But each program is different, and the budgets are certainly different across different programs. So.
Yeah.
How do most Balance owners approach you about their own thoughts or misgivings or approvals, or their own feelings about carbon when they come to you and talk about carbon components, rigs? What is the typical, or is there a typical answer from
I think that
Balance owner?
When they look at, because all of our boats are carbon reinforced, they're getting our standard boat. I think it's when customers are interested in getting carbon enhancements to their boat. Let's not talk about spars, I'll talk about that in a sec. They're either doing it because they want to increase their performance a bit, they want to go even faster, or they're doing it because I want this extra 500 pounds of weight saving so I can put 5 dive tanks in a dive compressor, and I won't be penalized for carrying this extra kit, right? So there's that for people. Like we have one customer that did a couple of those because he plans on going to the South Pacific and living off the grid for as long as he can. And so by buying himself the additional payload, he won't suffer any, speed degradation, right? So there's that equation. And I think those that get carbon masts typically are people that I think they come from a racing background, a monohull racing background, a lot of them. They love performance and they have the money and they really appreciate the stiffness of the carbon spar and they reduce pitching of it. But it's certainly not a quote unquote value decision, right, at all. Yeah.
And what percentage, Phil, of your owners do come from racing backgrounds, do you believe?
You're talking about, real racing background, right? There's racing backgrounds. Club racing or like high level
Well, I know not everybody's a Patrick Shaughnessy here that they're coming in from the Grand Prix.
Right,
race.
right, yeah. Well, you know, one of our owners, 526 owners, Mark Thornborough, he's a real ace sailor. He won the Etchells Worlds last year. But Mark's funny, you know, because Mark said, look, you know, I've got my boat to go cruising and living on, and when I want to race, I'll go one design. Like I didn't buy my catamaran to race, but of course you can imagine anybody that's that performance oriented, he cares about how his boat sails. So he's talking about the sails all the time and what you know, what's the right shape. Yeah, it's a pretty good percentage of them. I love the monohull converts, to be honest. I really like the monohull converts. So those that grew up from a long life of like club sailing, club racing, you know, that have a passion for yachting as a sport and activity. I've enjoyed those customers because I feel a lot more confident when they get their boats too, that they have the experience, you know, to use their boats and not damage their boats, and right, just in general. Yeah.
Well, thanks, guys. I think that covers the carbon aspect of our talk, and let's move on to the next installment, which will be talking about designing and building safer catamarans.